So we're still working with the law of sines. That's what we did on Friday. So we did the law of sines on Friday, learning how to apply some trig to oblique or non-right triangles. The law of sines is still the law of sines. So that is the sine of angle A over little a equals the sine of angle B over little b, which is equal to sine of angle C over little c. And remember, the ABC stuff, whatever, it is what it is, but it just means the sine of an angle over the side that's across from it, okay, in whatever situation that you have. And so we did that with angle, angle, side, or angle, side, angle. Really either, as long as it just means that I had two angles and a side, and I was able to find the other side. Today, we're going to be finding angles, so we're using side, side angle, which was not something you could use to prove triangles congruent because there's no ass in geometry, right? So let's talk about why you couldn't use it for that and what that means for us here, because it was the ambiguous case. It's still the ambiguous case, and that means that we got to do a little something extra after we find our answers. So basically, if you're going to use the law of sines to find a missing angle, because this gives me two sides at an angle, SSA is different than SAS. Okay, that'll require the law of cosines. But that two sides and the non-included angle looks like this. I would know these two sides and this angle. So there's two sides and a non-included angle. If it was side angle side, I would have angle C instead. Because that is the information that you know. The information you don't know are the other two angles and this side length, which means really this could be arranged more than one way. I could have it looks like this, and this would say, all right, I know angle B and the side across from it. I know this side, so I could find the angle that's across from it. But angle A could be one of two different things. Because since this side length and these two angles are not set in stone, meaning I don't know what they are, this side could swing in here and look like this. Where this would be the same side, so CA, this would still be that same length right there. And instead of having this big triangle here, my triangle would look like this green one here, where I still have the same two side lengths and the same angle, but clearly these two angles and this side length are completely different, okay? So when that happens, this is angle A, which I was looking for, right? And now I've created this little isosceles triangle here, so it's the same as this little angle right here. But the angle inside the triangle is now something completely different and clearly a lot bigger, right? So I have two options for my angle. The angle could either be this measurement or it could be this measurement. And since these two are the same, you can tell that my two options here would have to add to give me 180. So I'm going to have to find not only one angle, but I'm going to find two of them, but then I got to check some stuff. So let's talk about what we know and what we're going to have to check. So this says, watch out. When finding angles, it's possible to have one solution, two solutions, or no solutions. Okay, that's why this is called the ambiguous case. All right. So, sine function. The sine function always has a range between blank and blank. So I want you to think about all of the possibilities when I say, what is the sine of whatever angle? Like the answers that you would give me. And this is usually hard to dig out of people's brains, so I'm going to draw a little picture here, and maybe this will help us. So tell me, if we go around the circle, here's pi 6. What's the sine of pi 6? 1/2. What's the sine of pi 4ths? √2 over 2. What's the sine of pi 3rds? All right. And then what is the sine of pi 1/2? 1. Then I'm going to go to 2 pi 3rds, which I'm right back to here, which is √3 over 2, right? So I start going back down. So what's the largest answer, the largest number you're going to give me as an answer to what is the sine of blank? 1. So you can't give me any answer greater than 1, because once I get to 1, I start decreasing again, right? So what's the smallest value you could possibly give me? -1, yeah. So the range of the sine, when I say what is the sine of whatever angle I could possibly give you, it doesn't even have to be a special angle because it could be a decimal. The answers have to be between -1 and 1, right? So that's going to be important. We'll revisit that when it's necessary. Now, angles with a positive sine function can lie in quadrant blank or blank. So we know everything's positive in quadrant 1. Where else is sine positive? Quadrant 2. So think about that as far as what we're doing with our triangles. That gives me angles between 0 and pi, or 0 and 180, and that makes sense because those are the kind of angle measures that are inside of triangles, right? All right, to find the other possible angle, so when I told you up here, we have two possibilities. Well, the two possibilities are always going to add to give me 180 because they're a linear pair. So if I know one of them, I just find the other one by subtracting from 180. Then we also know that the sum of the angle measures in a triangle is always what? 180. And then no triangle can have two blank angles. There's actually more than one answer for that, but we're not dealing with right triangles, so no triangle can have two right angles, but we're not dealing with right triangles. So they also can't have two obtuse angles. That's going to be something that's important for us to recognize as well. Okay, so just little reminders of things we kind of already know that'll come up in our work here. All right, so we're supposed to, we have information about triangle ABC is given. We're going to check our answers and give all possibilities. So let's look at number 6. I'm going to draw a picture because I don't have one. Doesn't have to be to scale, just something that you can label. So here's triangle ABC. Let's see. Measure of angle A is 60 degrees. The length of AB is 30. The length of BC is 27. And I want to find the measure of angle C, so I'm going to call it theta. Okay, so I can set up my proportions, so I can use the law of sines. This theta that I'm looking for is across from 30, so I'm going to say the sine of theta over 30 equals, and then 60 is across from 27, so I have the sine of 60 over 27. So when we set up the other proportions, we cross-multiplied and divided, which is fine to do here too, but you can kind of save a step. You don't really have to do that. We just need to get this by itself, so all I really have to do is multiply by 30. So that'll give you the sine of theta equals 30 times the sine of 60 over 27. But I don't really care about the sine of theta. I want theta. So how do I get theta from this? Inverse. Very good. It's not division, which I've heard a few times because this is not multiplication. I have to take the sine inverse. So theta is equal to the sine inverse of 30 times the sine of 60 over 27. And then that's when you go to the calculator. So grab your calculators. They should be in degree mode, unless somebody's messed with them, and I don't think they have because I haven't had an issue with that. So type that in. Let's see what we get. Should get 74.207. Okay, but remember, we're using the law of sines to find an angle, so there's two possibilities. So I find the other possibility by subtracting that from 180. So on these calculators, all you have to do is 180 minus and hit the answer key, which is right next to the equal sign, and it'll take care of business for you. And you should get 105.793. If you're not getting these numbers, let me know. We'll figure out what's going on. Okay, now we have two answers, but that doesn't mean that they both work. Maybe one of them works, maybe none of them work, maybe both of them work. So here's how you figure that out. When you use this angle right here, like for either one of them, when you put them back in right here, these two have to add plus this one. All three of them would have to add to give you 180. So when I add these two together, it has to be less than 180 because I got to have some room for this angle right here. Does that make sense? So I need to take that 60 degrees and I'm going to add it to that 74. And you don't even have to actually do it on a calculator. I mean, you can see what the actual number is doesn't matter. Is that going to be less than 180? Yes. So that's less than 180. So that's good. Then I also need to take 60 and add it to the 105 number again, don't really care exactly what the answer is all I care about is that less than 180? Yeah, it's less than 180, so that one works too, which means both of these are my answer. Okay? We good? So you find an angle, you got to find your other option, and then you got to check them both to make sure they're going to work. Okay? And again, maybe one of them works, maybe both of them work, maybe none of them work. It happens. Okay? We good? All right, let's look at number 7. So I'm going to draw my triangle again. Angle C is 89 degrees. AC is 34. AB is 26. I want the measure of angle B. So B is my theta. It's across from 34, so I'm going to have the sine of theta over 34 equals the sine of 89 over 26. And I know you know you're supposed to take the sine, cosine, or tangent of an angle, so make sure that you're actually putting the numbers in the right spot. Okay. So then I'm going to multiply both sides by 34, so I'm going to get the sine of theta equals 34 times the sine of 89 over 26. Then I want theta, so that's the sine inverse of that. 34 times the sine of 89 over 26. And then put that in your calculator. And when you put that in your calculator, what happens? Error. You're supposed to get an error. Now, could mean that you did something wrong, but even if you do it right, you're supposed to get an error on this one. So here's what I want you to do. I want you to type in just this part. Just that fraction. So we can see what we're trying to take the sine inverse of. You should get 1.3074 something, right? So what this is asking is, what is an angle that's going to have a sine value of 1.3? Well, is there one? No, because what's the largest sine value you're going to have? 1. So if your number is more than 1 or less than -1, then you're going to get an error because an angle doesn't exist. It doesn't make any sense. So when you get an error when you're typing this in, it doesn't guarantee you that this is what's happening. Maybe you did type something in wrong. So if you're not sure, if you just type that part in, you can double check what that number is, and then you'll know. Okay? So in this case, I can't do this. This isn't going to work. I'm not even going to have a triangle, so my answer is just no solution. If you don't have any angles that work, it's no solution. Okay? What questions you got? We good? Awesome. All right. So let's look at number 8. So draw my triangle. ABC. So angle C is 102, and clearly my triangle is not to scale, but it does not matter at all. AC is 21. AB is 24. I am looking for angle B. So my theta is across from 21, so when I set this up, I will have the sine of theta over 21 equals the sine of 102 over 24. Multiply both sides by 21. So sine of theta equals 21 times the sine of 102 over 24. So theta equals sine inverse of 21 times the sine of 102 over 24. Okay. Then find your angles. And how many angles should you have? 2. One of them should be 58.857. You subtract that from 180. And your other one is 121.143. So then we check them. I have a 102 up here. So 102 plus the 58 degrees, that is less than 180. So that's good. But then when I take the 102 plus the 121, that's greater than 180, and that's not good. So this one doesn't work, and I only have one answer for this. And it's not working because every triangle can only have one obtuse angle. I already have an obtuse angle here, so I can't have another one. That's why it makes it more than 180 and why it fails. What questions do you have? You got a question? You sure? Okay. All right. Y'all do number 9 on your own. So those are the 2 angles I got. Do y'all agree with that so far? Okay, so is the 37-degree angle going to work? Yes, so that's good. Is the 142 going to work? No, so this one doesn't work, and this is my only answer. Okay, we're good? All right. Now you do number 10 on your own. Unless there's any questions on that. So these are the two angles I got. Let's talk about reasonableness of an answer. This angle is 30 degrees. This one's 31. So they're pretty close to being the same value. Does it make sense that they're pretty close to being the same value? Yes, because the sides across from them are pretty close to being the same value, right? So it's good. All right, so this 31 degree angle, is it going to work? Yes. Is the 148? Yes. It's like really close to 180, but that still leaves room for an angle, so it's fine. And they both work. What questions you got? We good? All right, we're not going to do number 11. Just remember that you always have to check them both, because maybe even after you get two angles, maybe neither one of them work. That's definitely a possibility. Okay? Any questions at all? Awesome.